All right, surface area and volume. Here is almost everything you need to know. Here are my tips and tricks and some common mistakes. The first thing for this topic, surface area and volume, okay, I think you'll find that it's a very formula-heavy kind of topic. My first tip is to be familiar with your formulas, okay? Yeah, and that's a really good question, Ben, because fortunately for you guys, so Ben asked, do you need to memorize them or can you just read them off your sheet? You have all the formulas that you need on your sheet, okay? But the way that I see this, it's kind of like imagine you were reading a text, right? And I remember, if I think back to primary school, there were always texts when I read them. They always get to this one word I'd never seen before. And then you go up to the dictionary and you look it up and you're like, okay, cool, that's what that means, right? This is kind of what the formula sheet is like. Every time you need to use that formula, if you had to go back to the formula sheet to use that, there's nothing necessarily wrong with that, right? But what's the issue there if you have to go back to the formula sheet? You are wasting a little bit of time there, right? Okay, so it is costly in that sense. If you have to go back to the formula sheet every time and know what to use, okay? So in that sense, it can actually be helpful to memorize them even though you get them. With surface area and volume, okay, there's actually not a really wide range of questions that they can ask, okay? Here are the three types of questions that you can really be asking. Okay? The three types of questions. First one is, it's a very vanilla kind of question, so it's like, my favorite ice cream flavor. You plug and play, right? So that's just like putting a values into a formula and then getting some answer. So maybe it's the surface area, maybe it's the volume, you just put it in. The next one is, they can make it a little bit trickier.
What's plug and play?
So you have some values and you just put it into a formula. That's what I mean by plug and play.
Yeah, I don't understand that. What's the vanilla?
Oh, it's just very basic, right? Very basic. The second type of question is, they try and mix things together. They call these Neapolitan. They call it composite solids. Okay, that's when you put multiple things. Yeah, you get the biscuits and you get the chocolate and mix it all together. Does anyone know the last type of question? These are two types of question. So we're just putting it in, straight in. We're putting things together. Question is, there's actually a third type of question that you can be asked. It was in your first test, if you think back to it. The chocolate is not the type of question.
Composite solids.
Composite solids. So it's when you put multiple solids together, right? The third type of question, year 10, is, it's actually the reverse of this. So it's when you're asked to work backwards.
Yeah, that's what I was just about to say.
Oh yeah, nice. Say it next time, Flynn. So working backwards. The second one is composite solids. So when you put multiple things together. So these are three types of questions. Just putting formulas in, putting multiple formulas in to make different kinds of shapes, and then the last one is working backwards. Okay, I'll show you all those examples today. Let me talk about those common mistakes first, though, because these are things that can cost you so dearly in the exam, because every mark counts, but they can be corrected so easily. Okay, when you're working with surface area and volume, what do you always need to include at the end of your answer? Right, units, right, units. Such an easy thing to add, but it can cost you so dearly. Units, right? So any units, it could be millimeters, square centimeters, cubic kilometers. Depends what you're dealing with. Yeah. Maddie had a question. Okay. Yeah. But here's something that these can actually help you, though, right? Just as a note, right? There's a close link between some of these, right? So, for example, for units, right? We notice that for length we use millimeters, for space we use square centimeters, and you use the square there, and for volume you use those cubic units, right? Those can actually help you memorize some of the formulas. Because, for example, the surface area of a sphere, if you go to that one, Emily, what's the surface area of a sphere formula? 4 pi r squared, okay? And if you look at the volume, Abby, the volume of a sphere, Can you look in your formula sheet and tell me what that is? Yeah, volume of a sphere. Yeah. 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 Pi r cubed. If you look at these, right, sometimes there is a hint in the formula itself to help you remember which one's which. That squared there, that's talking about surface area space, so that's that one there. The volume of a sphere, cubed, well, you know that's talking about the amount of mass that it has, right? Not for surface area and volume, we don't need. Yeah, yeah, that would be, yeah, if they're asking that. Two more things. With the formulas, right? I said that Ben asked, you need to memorize the formulas, okay? Again, you don't necessarily have to, but my emphasis is to be familiar with them, right? Because if you look at, for example, have a look at the surface area of a cone. Look at this one here. Pi r squared plus pi r L. Can you tell me, Corey, what does that L actually refer to?
Perpendicular height.
Why do you say that, Flynn? And this is what I said, right? You don't have to memorize the formulas, but at the very least, we have to be familiar with how they actually work. Pi r squared plus pi r L, okay? If you're looking at this, the r is referring to the radius of that circle on the bottom. That L there, it's actually referring to the slant height, right? It's referring to this length here. Well, he said perpendicular height. Yeah, that would be this guy here, right? Okay. So the second common mistake is mixing up variables. Okay, mixing up variables.
You get slant height.
Often they'll give it to you, right? For slant height, often they'll give it to you. Or you could use, maybe you might be asked to use Pythagoras' theorem here to find the slant height. Yeah. Yeah. So mixing up variables, very common mistake.
Wait, so those can never be not right angles?
Well, the perpendicular height by definition means right angle. Right? Yeah. And last one is, here's the last common mistake. When we're looking at composite solids here, not finding all areas or finding too many. Okay, last one. Not finding all areas or finding too many. What I mean by that is, yeah, so when we're looking at surface area, right? Surface area is only talking about that outside component, okay? So looking at this one, you can see really clearly there is a circle within that one. And some people may see, oh, okay, there's a circle here, I've got to add that in. But if surface area is only the outside component, then we only want to find that outside part. Similarly, they may not find all the areas that are necessary. For example, a really common one was, in your test, you got something like this. It was the surface area of a hemisphere. And so everyone saw, okay, surface area of a hemisphere, I would just halve this thing. So that would be 2 pi r squared. But what are they forgetting?
The bar.
Yeah, well, there's a bit on this top here, right? That would be just the area of a circle, which is just pi r squared, right? And then you'd have to add that on.
Isn't that just a cone?
Sorry?
Isn't that just a cone?
Well, this is actually a sphere. This is a hemisphere, right? Half of that, right?
Oh.
Yep.
It looks really like a cone.
Maybe if I draw it more like this.
Oh.
Is that better? Yeah. Okay, cool. So those are the common mistakes, and those are my tips and tricks. I'll give you 3 examples to try of each of those, okay? Of each of these levels.